Find the shortest path from A to F in the weighted graph shown on the right. So we want to start from A over here, and we want to finish at F over here. The first thing that we do is we start off by labeling A, which is our starting vertex, with a value of 0. And then once we do that, we then look at the vertices that A is connected to, or adjacent to, and we have these two vertices B and C. And then what we do is we also label those. So for B over here, to go from A to B, we have to travel 2 units. So we label B with 2. To go from A to C, we label C with 6 over there, because it's 6 units to get to there from A directly. And then from this point onwards, we circle out of these two the smallest value, which is obviously B. Then from B, we scan all the other vertices. So B is connected to E, it's also connected to D, it's also connected to C. To go from B to E, you can see that that over there is a unit of 2 units over there. So starting with B's value, if we add on that, we end up with 4. And if we start at B and we go to D, we have to travel 3 units. So starting with 2, if we add on 3, we'll label D as 5. And then if you start at B and go to C, we travel 2 units. So 2 plus 2 is 4. Now because 4 is smaller than 6, we're going to cross out the 6 over here and relabel it as 4. And basically out of our 3 new vertices, we have 4, 5, and 4. And we circle the one with the lowest value. In this case over here, we've got C and E both having the same value of 4. It doesn't matter which one you circle, so I'm going to choose one, and the one I'm going to choose is going to be C in this case. From C, I then scan all the other vertices that are adjacent to it. So basically I've got D over here, and D over here, we've got the original value of 4. If we add 1, we get 5. So that one over there is unchanged. And if we go from C to A, well, basically we have to take 4 and add 6, but our original value is 0, so we leave it unchanged, because 0 is less than 10, obviously. 10 is 4 plus 6. If we go from C back to itself, back to B over there, then we have to take 4 and plus 2, which gives you 6, and that's no good because 6 is greater than 2. So basically, from this point onward, we can circle 5, because that is the vertex with the lowest number assigned to it. And then from D, we scan the vertices. So we've got E, and we've also got F. So over here we've got 5, and if we add on 2 to get to E, that gives you 7, and 7 is actually greater than 4, so we don't change that at all. Okay, so we leave that alone. And to go from 5 to, not from 5, but to go from D to F over here, we have to travel 5 units. So if we take 5 and add 5, that gives you 10 over there. And in this case over here, we circle the one that has the lowest value, which is that. And then from E, basically if we scan, we can see that we've got F over here. And to go from E to F, we travel 3 units, but we've got 4 over here. And this is 10, so we cross the 10 out and we replace it with 7, because 7 is 4 plus 3. And then finally, we circle the number that is lowest, which is in this case just 7. And now we've circled our graph. So basically, we've now got the answer. So the shortest path has a length of 7. So I'll write this down. So the shortest path, it has a length of 7. And to find out what that path is, we need to figure out how we got this 7 over here. So firstly, we started at 4, and then we added 3 to get to 7. And then we need to consider, how did we get the 4? Well, the 4 over here, it didn't come from the 5 over there, obviously. It came from the 2 over here, or the B over here. So we traveled like this. And then for the 2 over here, or the B over here, how did we get that label of 2? That label of 2 came from the fact that we started at A. So we need to kind of backtrack to see how we got that number 7, and if we can identify that, then we've got our shortest path. So it would be from A to B, to E, and then finally to F.